Viewers, in this tutorial we will continue with functions in C, and in particular this tutorial clearly explains the use of the fourth kind of functions, that the functions which will receive parameters from the calling function and which will return some computed value to the calling function. These kind of functions have found extensive use in programming circles wherever functions are implemented, because they may take some of the functions outputs as inputs and as the receiving parameters, and they will also facilitate to continue the calling function for the further computation. That means it makes the calling function continuous. It can hop from one function to one function. One function's output can become inputs for the other function. So in that way, these kind of functions are expeditiously used in C and elsewhere also. So they are typically called as non-void functions with parameters, and this kind of functions return a value and will have parameters, that is data received from the calling function. They will look like this: float, compute, int and float, character, option, int. And these two are names of the functions, and these two are kinds of value they return, and these the things that are contained in the bracket is called as kind of parameters that it receives. And put together, the float, the kind of value a function returns, the name of the function, and the parameters in the order that is specified, collectively called as signature of the function. So signature of the function cannot be different whenever we declare the function as a prototype. Whenever we just write the heading of the function during the definition stage, and while calling anyway, of course this thing is missing, and here the name of the variables will be mentioned. And in this tutorial we will cover at least 7 function related programs, and each one of them is different in its own term. Example 1 is about the program that collects the principal amount from the calling function, computes the simple interest, and returns the same value, that simple interest, to the calling function. That means it receives the principal and returns the simple interest, and here it is. And we have used another header file called as IO_manip, that is input output manipulation header file, because this will facilitate, particularly when we execute the programs in Turbo C++ environment, Turbo C++ IDE. This is an essential thing to be included, because it defines the various formattings for the input and for the inputs and for the outputs. Therefore, since we want to bring in some kind of a formatting over here, we have included IO_manip.h. If you are working in Turbo C environment, inclusion of this thing is not required, and even it is not available also, and stdio.h will serve the purpose. So float simple interest, the name itself is given in such a way that it gives a notion of what exactly it does. Float principal, this is the parameter it has been received, and this particular function is defined as a global function. Therefore the main function need not contain any prototype, as it was said earlier also. So float term, that is number of years the principal amount is kept, rate of interest is 6.5, it is assumed, and it is 6.5% instead. In fact, it is interest. This is the value that is to be returned by this particular function. So put as how many, and we are using put as function over here because it is very simple. If the caption or guiding or some kind of a prompt, user prompt that you are going to give is a typical literal constant, something like this, without any control characters, control characters, put as is the best function. Okay, how many years to be deposited, and anyway it's going to leave the new line also, an empty line. Therefore /n is not required. If you put /n over here, it's going to create 2 empty spaces, empty lines. So scanf percentage of term is read, interest is principal into term into 6.5, that is divided by 100 in order to make it 6.5%. principal has been supplied from the calling function. So it will calculate the interest and promptly return the interest to the calling function. This is local variables, the term, rate and interest, and return is the keyword. Function is made global. Now here is the main function, float, principal and simple interest, and you should see the name over here. The value that is returned by the function has a different name, and here it is as a local variable in the main function. It is succinctly denoted as SI, simple interest. Printf enter the principal amount. This should be sent to the called function, therefore it is read over here. It is taken as input, and percentage of principal, simple interest is equal to simple interest principal, and this is the calling stage. And as soon the control will be, as soon as the compiler looks at this expression, it's going to send the control to the definition position of this particular function, and this function will be put to service. It will become a process, and upon calculation of the simple interest, it will return the simple interest, which will be fetched by SINT, that is simple interest, and it is printed over here. And here you can notice some kind of a formatting is done, and this is defined. How this should work is defined in IO manip fetch, and whatever the value that comes through as simple interest will be cut short to 2 decimal places of accuracy. No prototype, as the function is made global. And argument passing, this is the argument, and when it is defined at the definition stage, it will become a parameter, formal parameter, dummy parameter, or an alias. Okay, in example 2, the program has a function that checks whether a given integer is a perfect square or not. So here is the function, and we need math h because we have to input the integer and we have to put it into square root. Let us say the example is 4 or 16. When 16 is taken as a square root, what it gives is 4, and once again if you take the square root, it will be 4 again. 4 into 4 will be equal to 16. On the other hand, if we try for 15, it's going to give us 3 into 3, it is going to give us a 9, because integer arithmetic will lead to truncation. It doesn't give us 3 point something as it should be. Therefore 9 is 15 is not a perfect square. 15 as an example. So here number, this is the variable which will receive the value to check whether this particular number is a perfect square or not. The function is named once again is perfect square integer. Okay, it is doing some kind of a checking business, checking kind of a function, therefore it is named this way. Enter an integer. Okay, integer is given as an input, and if is perfect square num, that means it is used, the function, the returning value is directly placed in the if statement. Okay, instead of this we could have gone roundabout. That means we should have declared a separate variable, and this separate variable will receive the value that is returned by this particular function. Anyway, this function is returning, if the given number is really prime, it's going to return 1, otherwise it's going to return 0. Therefore it sends some kind of a boolean value. Therefore it is good enough. If is perfect square num, anyway, if this brings in 1, that is if the value returned by the function is not equal to 0. Okay, the meaning of if of x, let us say for example, if x, if we write somewhere in the program, it means if x not equal to 0. Therefore here also, in the same token, here also, if the value returned by the function is not equal to 0, that means if it is 1, then it should be a perfect square, otherwise the number is not a perfect square. So we are this kind of functions, we will show, the programmer will be showing some kind of a brevity over here. Therefore the functions, this kind of functions which will send boolean values, and it will be cryptically questioned in a relational expression in the calling function, and anyway the things are resolved. And here this is the function that is defined, integer is perfect square, integer x. You can notice there we read the input as num, here the alias is x, that is the formal parameter is x. Okay, it can be done this way also. So if x equal to square root of x into square root of x, that is, if it is a perfect square, this will be definitely equal to x. If it is 16, square root of x will give us 4, and this square root of x will also give us 4. 4 into 4 will become 16, therefore 16 is a perfect square. On the other hand, had it been 19 or something like that, it would have given some kind of a truncated value, and it will never be equal to the original value of the number. So if this happens, it will return 1, otherwise it's going to return 0. And here is an output. Enter an integer, 81 is given, 81 is a perfect square. Now, the next example 3 is all about checking whether a given integer is prime or not. So this goes in a similar way as that of the second example. Anyway, let us go through this for the sake of completeness and for the sake of clarity. Here the input is named as num, and the function is named as is prime. Int is prime. This is the prototype. The value, the kind of value it returns and the kind of parameter it receives. Put as enter an integer. So an integer is given, and it will be stored in the variable num. If is prime num, if the value received by the function is none other than 0, therefore is prime is also a boolean kind of value returning function. Anyway, justifiably so. Printf %d is a prime num. Okay, otherwise the number is not prime. So that will be printed by the calling function. Let us see how exactly this is programmed in the function. So this is the definition of the function. Int is prime, integer x. So the name alias has been changed. Integer I to run the for loop, flag equal to 1. Okay, and this is used for checking whether it is a prime number or not. If I equal to 2, and we have done this program in two ways. One, to check a number, the other program to generate prime numbers up to a particular value. So my respected viewers can give a relook for this particular example in the tutorial series named as iterative constructs in C. Okay, so in order to check a number to be prime or not, it should be divided starting from 2 up to half of its value. In between, if it gets divided, that means if the modulo division returns 0, so x mod I equal to 0, then it should not be a prime number. It's not a prime number. Therefore, flag will immediately become 0, and we are telling break. That means the control will come over here. It will break. The control will be thrown out of the block where break appears. So it will come over here. If this is not true, flag should be still 1. If flag is 1, if flag is not equal to 0, means if flag is 1, return 1, otherwise return 0. So here there is an output. Enter an integer 111. 111 is not a prime. Next, this program computes NCR and NPR, that is combination and permutation. Combination of n items selecting R at a time, permutation of n items selecting R at a time. And you know NPR should be always be will be of a higher value when compared to combination, because combination of A and B is just 1. Okay, A, B, that's all. As far as permutation is concerned, A, B, B, A. Okay, the position of individual object matters as far as permutation is concerned, and it doesn't matter as far as combination is concerned. Combination points to selection of items, while permutation points to arrangement of items. So integer n, this is the number, and R, okay, how many at a time, permute, combine. This is the variables which will collect the answers from the function. Okay, a function will compute permutation of n items selecting R at a time, and combination is another function which will compute the combination. But anyway, in both the cases, the formula contains, both in the numerator and the denominator, the factorials. Okay, as far as NPR is concerned, it is n factorial divided by n minus r factorial. As far as NCR is concerned, it is n factorial divided by n minus r factorial into r factorial. Therefore, it is enough if we construct a function for factorial, and it will be repeatedly applied in order to churn out the answer. Okay, enter the number of entities or objects, it is n. How many at a time to permute or combine, it is r. So permute is factorial n. divided by factorial of n minus r. This will be called and the value of n will be sent. When this function is called, it will be n minus r. First of all, this computation will happen, then the value will be posted to the function for computation. So it is the answers are written after obtaining the value of permutation. Then this is expecting a huge value. The function is defined as if it is returning a long int, because for example, if you give an input to be equal to 15, and if you declare this factorial, if you declare this factorial value to be short int, it's going to show minus values with minus sign, indicating some kind of a overflow. Therefore, whenever a function computes factorial value or function or anywhere, it's better we declare the answer, that is the factorial value, to be long int in order to avoid the overflow. Right? Combine factorial n minus r into factorial r. So this is the computation, and printf all these things. So here factorial n will be computed, then once again it will go to this particular function, and n minus r, first of all this will be simplified and the value will be sent and factorial computed. Here 3 places, 3 times factorial value is calculated, and as far as permutation is concerned, 2 times the function is called. Here long int factorial, integer n, integer I, fact equal to 1, this will collect the factorial value. Okay, I equal to 1 to I less than or equal to n, I plus plus, you know this, it's a primitive calculation. Anyway, fact equal to fact into I, return fact. Right, and this is the output, okay, which is being executed in a turbo C++ environment, turbo C++ IDE. Enter number of entities or objects 6. How many at a time to permute and combine? 2. 6 objects 2 at a time can be permuted 30 ways. 6 objects 2 at a time can be combined in 15 ways. Example 5. Okay, this program has 2 functions that will receive an array, and one will find the biggest element among the array elements, and the other function will find the smallest elements among the elements. Therefore, this is an example where you will and we will learn about how to send an array as a parameter, okay, and how to compute the other things, whatever that is required, very specific to the problem. Integer numbers, this is the name of the array, it will hold 20 elements, number of elements, any I to run the for loop, the biggest of the elements, which is found out by a function and received from the function, and the value of the biggest element received by some function named as find biggest, let us say find large will be stored in biggest. Therefore, this will become a local variable to the main, and smallest is also in the same token as that of biggest. So we have named the functions as find large, integer, and you should notice over here, whenever arrays are called, whenever arrays are to be represented in prototypes, it is just like this. If it is a float kind of array, we would have written float opening square bracket and closing square bracket without any space, of course. Integer, this is possibly to send the number of elements, because whenever we want to work with an array and whenever we want to send elements into an array, the array itself is not enough, because the function won't be knowing as to how many elements are there in the array. Therefore in every call we need to send the array name as well as how many elements are contained in that particular array. We will see that anyway. Find small and find large will do the designated tasks as the name itself would imply. So enter the number of elements are taken, enter the elements are entered, and it will go and get stored in an array called numbers. And this is the array type, of course, array type. Right, now the biggest among all is find large, and here you can notice some kind of a brevity is shown while programming, and we are calling this function within printf statement itself. So this is function in a function. Anyway, the BODMAS rule is applied over here. Anyway, this will be first executed, okay, with these parameters, and whatever the value that is gotten from the returned value of this find large will be printed over here. In the same token, the same thing, a similar thing will be done with this printf statement also. So here the change is we have started including We have started including the functions within printf statement also. We have already used function names and function call statements in if statements also. Okay, by doing this, I think we are using the entire echelons of this programming in C. So for integer find large, the function is defined, and here you can notice the name of the array is changed. There it was numbers and here it is n. So n becomes an alias for this particular array. Okay, integer n, it is retained as it is. Okay, integer I biggest equal to n of 0. That means while we find the biggest element among all the elements in an array, we will assume the very first element to be the biggest. Okay, therefore the comparison will with the other elements will start from first element, the second element. So I equal to 0, I equal to 1, I less than any, I plus plus. So it will have to go for the last element also, comparing each and every element. Okay, and the comparison happens like this: if biggest is smaller than the next number, so biggest is the first number, and if the biggest is smaller than the next number, then biggest will become n of I. Okay, this biggest will be overwritten by the next element. So it will be cycling around like this, and at the end of this for loop, after the completion of the for loop, what comes out is the real biggest, and it will be promptly returned to the calling function by this return statement. Name of the array is changed. Okay, this is to be noticed. Anyway, integer find small, of course this is converse of that. Integer I smallest equal to n of 0. The first one itself is assumed to be the smallest element, and this will start from 1 and it will go up to the last element. Okay, last element should be in the n minus 1th position, because the first element would have occupied the 0th position. So if there are 10 elements, the 10th element will be 9th cell. If smallest is greater than n of I, okay, the assumed smallest number is greater than the next element, then the next element will become smallest, return the smallest. Anyway, upon the completion of this for loop, what comes out is the real smallest element. Okay, here is an output. Okay, enter number of elements 10, enter the elements are entered one by one by hitting the enter key, and what we get is biggest among all is 123, somewhere over here, and smallest among all is minus 13, which is somewhere over here. Okay, it has really worked. So example 6, in this example we make use of functions that compute average and standard deviation. Okay, we have a function to compute average, and upon getting this average value will become one of the inputs for this function, which would find out standard deviation. So in this particular situation, of course, these kind of functions are of immense help, because they receive some parameters, they will compute something, and this computed value will again become some input value for the other function. Okay, and this kind of function will facilitate, as I said earlier, for the calling function to continue further making use of these functions and making use of the values returned by these particular functions. And here again we have used iomanip.h, okay, to format the outputs. Okay, integer numbers, this is the name of the array, number of elements I for running the for loop, float average and standard deviation. You remember the average and standard deviation will turn into float values. Float find average, it receives the array of integer type and number of elements which is of integer type. Float find standard deviation, it has to receive the array which is of integer type, number of elements which are of integer type, which is of integer type. Float, this should be average, because the formula for standard deviation has average value, okay, as one of the parameters. Okay, put as enter the number of elements are entered, enter the elements, so elements will be entered one by one. Now average equal to find average numbers, the array name is sent, and any number of elements. So as soon as the compiler looks at this, the control will be passed to that particular definition of the function, and the function would return the average value. This returned value will be poured into this particular average, which is a local variable in the calling function. average of all numbers percentage 0.2f. That means otherwise if we not placed this particular format specifier, we would have got a lengthy answer which is accurate up to 6 decimal places, which is not required. Therefore we have cut short the number of accuracy, the accuracy to second decimal. Okay, therefore average will be poured over here, and standard deviation is obtained through as a returned value from this particular function. Find standard deviation, numbers, the array is to be sent, number of elements are to be sent, and the average value obtained over here should be sent. So therefore this particular function is feeding this particular function. Okay, so standard deviation is printed, and variance is a square of standard deviation, that is also printed, and main ends over here, and we have to now define find average first. Float find average, integer n, okay, name is changed, integer ne, sum equal to 0, float average, and we have computed sum is an integer, you remember over here, and when we try to calculate average, had we forgotten this, we would have written sum divided by ne. This is an integer, this is an integer, therefore integer division, as I told in my previous discussions, that integer division is very dangerous because it is going to truncate. In place of 3.5, what we get is 3 only. Therefore this one of the variables should be turned into different cast altogether. Therefore this can be done by using this typecast operator. It should be written in the flower bracket because this round brackets are in the parentheses because we have run this program in Turbo C++ environment. Had it been Turbo C, these brackets are not required, parenthesis is not required. Instead we need to place the parenthesis over here. Okay, or we can write side by side in C return average. In C++ we need to write like this only. So this function has returned average, and here it is used over here, integer n, integer ne, float average, and here we have a numerator because the formula is this, and we will generate this numerator, divide this by n minus 1, and we will take the square root only to get standard deviation. So numerator equal to, numerator is set to 0, numerator equal to numerator plus n of I, that is the xi, each and every element, minus their own average, into n of I into minus average. So this is xi minus x bar whole square, and it is added. So this is implemented, sigma is implemented, and what we get at the end is the complete squared and added value, and now standard deviation is computed as square root of numerator divided by ne minus 1, and this function promptly returns standard deviation. Right, here is a output sample. Enter number of elements 10, enter the elements, all the elements are entered, average of all the numbers is 57.70. Had we not used the format specifier, it would have printed up to 6 decimal places. Okay, because this is of accuracy. This is accuracy. Okay, accurate up to 6 decimal places. Okay, and standard deviation is 21.15, variance is this much because it is a square of standard deviation. 21.15 square is 447.12. Right. The last example that we are discussing is, once again there is a lot of learning over here. This program has a function that checks whether a given array is sorted, unsorted. If sorted, whether it is in ascending order or descending order. It will also communicate to the calling function if all the elements are equal. Therefore, we need to have some numbers. If the array is in ascending order, the function would send 1. If it is in descending order, the function would send 2. If all the elements are equal, it may send 4. And if it is not ordered, it may send 2 or whatever that is missing. Okay, we will just go through this very carefully, and we have included process.h over here because we need to exit. If the array is not sorted, there is no fun in continuing in comparison. Okay, therefore in order to check whether an array is sorted or not, each and every element is to be compared with respect to the next. Therefore if there are n elements, n minus 1 comparisons will happen. Okay, enter the elements are taken. Now it is sent to the array, sorry, the function called as check array. Okay, numbers, the array is sent and number of elements is sent, and what it brings back is check index, a value, either 1, 2, 3, 4 for different conditions of the array. If check index equal to 1, array not in order. If check index, else if check index equal to 2, array in ascending order. Else if check index equal to 3, array in descending order. Else put as the elements are equal. Okay, we will see how exactly it is done. Check array integer number. So here we have used the same name. Whenever we use the same name of the array particularly, okay, the calling function has numbers and the called function has also numbers. Therefore, in that case, it is essential to mention the number of elements that we set forth when we started the program. Here it is 20, therefore same 20 is carried. We can't afford to do mistake over here. We can't mention 10 over here. Okay, it will immediately flag error. It can be left empty also. Integer any, integer I ascending equal to 0 is a flag. If array is found to be in ascending order truly, then ascending will receive 1. If array is in descending order, this will receive 1, and flag to check whether it is unsorted. If the array is unsorted, flag will become 1. Okay, I equal to 0, I less than ne minus 1. Because if there are 4 elements, for example, 3 comparisons have to take place: 1 and 2, 2 and 3, 3 and 4. Okay, therefore ne minus 1, I plus plus. If numbers I, that is the previous element, is lesser than next element, if the input is something like this, 12, 13 and 14, the previous element lesser than the next element, the previous element lesser than the next element. Comparisons, 3 elements, this and this is compared, 13 and 14 is compared. 2 comparisons will happen. Therefore, if there are n elements, n minus 1 comparisons will happen. If this comes true for a particular input, 12, 13, 14, some kind of an array, something like this, which is already arranged in ascending order, then ASC remains to be 1 forever till the for loop is completed. On the other hand, if the input were to be something like this, 14, 13 and 10, which is in descending order, numbers I, the previous element is greater than the next element, then descending will be 1. And if the array given to the function is something like this, then descending remains to be 1, ascending remains to be 0. Okay, if the input were to be something like this, 14, 15 and 10, when 14 and 15 is compared in the first cycle, let us say ascending will be equal to 1, because the previous value is greater than the next, lesser than the next value. It is ascending. When 15 and 10 is compared, descending becomes equal to 1 in the second cycle. So before completing the for loop, at any point of time, in any cycle, in any iteration, if both ascending and descending remains to be 1, it's an indication that the array is not sorted. Therefore, if this is the case, if ascending is equal to 1 or descending equal to 1, in any of the cycles, okay, in any of the cycles, if this is found true, then return 1. Return 1 means it indicates the array is not sorted. Then we exit. Let us say if it happens something like this in the second cycle itself, there is no fun in continuing further. Therefore, it is a forceful exit. But what it returns is 1. That is very succinct. Now, if ascending equal to, if 1 is not returned, that means either the array should be ascending order or it should be descending order, or all the elements must be equal. If ascending not equal to 0, that means if ascending equal to 1, return 2. Else if descending is not equal to 0 or descending equal to 1, return 3. Else return 4 for whatever the type of array is. This function has 4, there is an important learning over here. This function has 4 return statements. Therefore, theoretically, any function can have any number of return statements. But each and every return statement should be condition bound, because for any given problem, only one return statement will get fired, or will get really actually sending kind of thing. Okay, that is the value which is being returned. All other return statements will become null and void. For a given array anyway, it is only one kind of input holds good, and therefore only one return will get fired. So with this, and this is the output, enter number of elements 5, enter the elements for 12, 32, 10, 46 and 2, array not in order. Okay, my esteemed viewers, with this we have completed the tutorial number 3 on functions, devoted to functions, and we will once again discuss some of the complicated programs or programs of engineering interest for which functions are built. Particularly, we will look into a mix of different kind of functions in the next tutorial, and whatever the programs that we discuss are not primitive kind of programs like this particular tutorial. But anyway, this is the starting step. I advise my particularly student community, my respected viewers, to any program that they venture, let it be modular, let them it is suggested that we should construct functions. Okay, it should be function oriented. For any task which might be repeatedly done in a program, functions will serve to its best of its capability. And it is suggested in computer programming circles that for every program we should implement functions only for assorted tasks. So with this we complete this tutorial, and if you liked this tutorial, kindly subscribe if you are not yet subscribed yet. Thank you and bye.